some clever clogs thought they could outsmart me by asking whether or not I had a method, another little song perhaps, for getting things out of log expressions. So we, in the last video, looked at how you get them into log expressions. So get an index expression, say for instance 3 to the x is 7. Into a log expression, we do that by dropping the base. So the base becomes small, we drop it down, we add in the 7 and that will give us x. That's the untangling method, if you will. I do have a method of getting things out of logs, and it's incredibly corny and cheesy, but I love it and hopefully it will help you. So let's have a lesson.
You raise me up so I can stand on mountains. You raise me up to walk on stormy seas.
Okay, that's enough of Josh Groban there, alright? So we're raising up. Let's raise up our log. Okay, so we're going to take our base and we're going to sing You Raise Me Up. Let's raise up the base. So we're going to make the base big again, and because we're raising up the base, our x goes flying up. Now, we knew that x had to be the index because that's the whole point of a log. Now, we're standing on mountains, right? Let's pretend we've got a mountain in there. We're going to have to stand on that mountain, which means we need to go over it and also over the lovely little stormy seas. Okay, so stand up and over the mountain, include your mountain, and land on the 2. Okay, so it's really bad, it's pretty tenuous, but it does the job. So we're going to take the little base and we're going to raise it up, and that was my attempt at singing. Walk over the mountain and land on the number that's currently big, i.e. your 2 or your half. So let's work out with the second one, okay? Take your base, you raise me up, 16 to the power of x. So I can stand on mountains, land on the half. Okay, now, in this case, and in this case, probably the log was going to be easier to work out. And again, don't forget we're discussing how we're going to use our calculators to work that out in class. If you do have one of the simpler calculators though, don't forget you can use your log box button, pop in your 16 in the base and your half in the box, hit equals, it will give you your answer. We will talk about how to use a graphical calculator on this, and now that we know how to get our things in and out of logs, we can talk about the rules of logs. So in class, what I might do is set some of you the challenge of working out why these work, but for the purposes of this video, we're just going to talk about what the rules are. Okay, so we have, in this case, the same base. We have base A. It could be anything. It could be a 2, it could be a 3, it could be a 12 trillion. Doesn't really matter, okay, but it is the same. And these two things are added together. And what that means is we can write that as a single log, base A, with n multiplied to m. So when 2 logs of the same base are added together, you can multiply the end numbers. Now, that has a nice consequence, obviously, for division, for subtraction. I gave the game away there. That would be n over m. Now, be very, very careful. It's not the whole log, it's just the numbers. This is everyone's favourite one because it can be so, so useful. We've got log base A to the n, again, anything, but this is raised to the power of b here. That actually ends up being b lots of log a to the n. So we've kind of moved down the base and multiplied, although don't think about it too much like that. You'll get yourself confused with differentiation. But we've got it raised to the power of b, and it's now dropped to become b lots of. And then the last thing is something that you probably have found out in your calculator already. If you have the same base and the number, then that is equal to 1. So that could be 7 and 7, it could be 12 and 12, it could be 1237 and 1237. It doesn't matter, but if it's the same number in both locations, it's a 1. So like I said, the challenge in class this week is going to be why. Why? So in the next video, we'll look at some exam questions, and then once we've done that and you're feeling pretty good, we can move on to index expressions, which uses all these tools, but just presents things in a little bit of a different way. You don't have to use logs till the end of the question. Right, see you in class.